Good afternoon, folks. You had a question already, John?
No, I wanted Dave Keita to come and introduce you.
Oh, yeah, he did that last year.
We would know who you are.
You're supposed to remember from last year. So good afternoon, ladies and gentlemen. Welcome to the Physics Colloquium. This is the first one of the year, and it's a tradition that we do a State of the Department address from the department chair. That's me, Carleton DeTar. So I introduced myself. John, so now you know who I am. Most of the talks are about physics, of course, and so the rest of the year we're going to be having physics talks. The organizer of the colloquium is Professor Stefan Leboeck, who's sitting in the back of the room here. And he wants me to remind you that these talks have a purpose, and that is for graduate students and other students to introduce you to physics that might not be the same as the ones that you're actually working on, the specialty that you're working on. And it's also just something also for the faculty to find out what their colleagues are working on or interesting physics in other fields. And so he wants to encourage everybody to come to the talks. And also, if you have any suggestions for colloquium speakers, there are a number of slots at the end of the semester that are open. And so please contact Professor Leboeck if you have any suggestions for exciting physics talks. So today, it's my job to give you a little recap of what's happened in the last year and look ahead a little bit in the next year, and then review some of the physics developments from our faculty over the year. Some members of the faculty have sent me information about highlights of their research, and so I'll try not to butcher it too much as I go through. So to begin with the traditional remembrances, so we lost one member of our family, namely Professor Emeritus Gail Dick, about a month ago. And he was a condensed matter theorist. He was at one point in his career chair of the department. He was also dean of the graduate school, and very much loved. Co-founder of Save Our Canyons, an environmental organization, very active in the community. So here he is. Rappelling down a cliff in the Tatoosh Mountains in Canada in 1949. There's going to be a memorial, some of you may know, September 28 in Libby Gardner Hall at 2 p.m. We have one new faculty member in this past year, and that's John Bells. Is John here? You want to stand up so people can see? Well, of course, you have a picture here, but there you are. Actually, he's well known to us because he was he was a research assistant professor for a number of years before he became an associate professor. And we had two faculty members advance to tenure this year. Doug Bergman, if you'd like to stand, and Adam Bolton, if he's here. Adam, yes. Congratulations. So to mention a couple of the departmental honors in the last year, Kyle Dawson got an early career teaching award. Professor Shanti Dimyad got the Myriad Award for Excellence in Undergraduate Research, and you'll probably see why later on. Shanil Dalasen got a faculty job at Minnesota State University in Mankato. We consider that also one of our success stories, that we have career line faculty or postdocs and so on who go off and actually get a real job of some kind. And then Lauren Simonson, one of our graduate students, was awarded university teaching assistantship, which is quite prestigious. We have a new dean of the College of Science, Henry White, and he's replacing one of our own, Pierre Sokolsky. So Pierre is undergoing this transition where he looks very distinguished and dignified here, where he removes his tie, and he can be very happy now. I don't know, Pierre's not in the audience, is he? Well, that was kind of wasted, wasn't it? Okay, we had a number of staff changes. Sari Gardner, who was executive secretary, left. Tamara Young, a new advisor, arrived. Tamara? There she is. Chase Adams left. Sean Merrill was promoted to executive secretary. So Sean, are you here? Yeah, wave your hand. Good. And then also Jordan Klepsy arrived. Wave your hand. Also at the front desk, you'll be seeing more of them as well if you ever walk into 201 GFB. We have a bunch of new postdocs. Well, this list actually includes a bunch who haven't possibly arrived yet. They're coming in September and October. But Ella Olegnik is now a postdoc with Professor Dimyat, Rasha Abbasi with John Bells, and Udara Abisekara is with Dave Kita. Are any of those three here? You could stand up. No? Not here. Okay. All right. Graduate students. We have new students, 17 new students, 10 men and 7 women. 7 of them are domestic, 10 international from China, India, Nepal, Austria, Lebanon, bringing a total to 14 countries represented in our graduate school. Would the new graduate students please stand up? Excellent. Welcome. Welcome. So our total enrollment in graduate school now is 101 PhD students, 1 master's. During the last year, we awarded 29 bachelor's degrees, 5 master's, and 9 PhDs. Our undergraduate enrollment has gone up thanks to some energetic recruiting by Lynn Higgs, our recruiter. We have now 293 undergraduate majors. That's a record total, of whom 239 are men and 54 are women. We'd like to get those numbers a little closer to each other, too, so we're working on that. Enrollment in our classes, we had an approximately 10% drop in the spring of 2014, and some people speculate that that is the missionary effect. The LDS Church changed the year in which young men go on missions, also young women, and so this meant that we lost some enrollment. Campus-wide, there was a significant drop in enrollment. That didn't affect us quite so much, because I think students are also realizing that physics is a useful subject to learn, and so they came to us anyway. Figures are not in yet for the fall of 2015. They will be in another week or so. We know that some of our courses are oversubscribed. Our undergraduate labs are bursting at the seams, and we don't have space for any more students unless we start meeting at midnight or sometime like that. Physics 3730 and 3719, both of these are also oversubscribed, and we're scrambling to try to do something about it. Ben Bromley, especially, who's teaching 3730, is figuring out how to shoehorn 55 students into a room that holds only 36. Our budget, it's very tight. We're still recovering from our recent faculty growth, so we don't have a lot of wiggle room. The good news, at least for students, is that there are increased scholarship opportunities at the university level. So you can look at the university websites to check those opportunities out. Event highlights. So one of the, I don't know whether you want to call this a highlight, but anyway, Halloween last year, we had a bit of a problem with a helium dewar holding about 100 liters of liquid helium. And those of you that might know something about cryogenics know that when these things get stopped up and the pressure starts building, they can be very dangerous. So we ended up evacuating our building, calling in the experts who flew in from somewhere or another to take care of the problem. and of course also involving the fire department and so on, canceling classes for that rest of the afternoon so everybody could go to a Halloween party early. Here's the doers sitting outside. They hauled it outside. This guy is wearing a face mask. That's one of the experts. The other expert has his face mask up here. I don't quite understand. That, don't do this at home. This is not the way you do this. And the Salt Lake Fire Department here. And there they are venting the beast. So everything was taken care of safely. Nobody got hurt. And everybody could come back to class the next day. Dave Kita wrote us a little ode to Robert Frost. Some say the building ends in fire. Some say in ice. From lecture demos, I've been inspired to hold those who favor fire. There's a little history in that one. But if it had to perish twice, I think I know enough of fate to say that for destruction, ice is also great and would suffice. So there you have it. A bunch of conferences organized by our faculty in 2013-14. There was the Trevor Fest for Trevor Weeks, who is a high-energy gamma-ray astrophysicist. Members of our department helped organize the conference. It was held in Tucson, Arizona. Unfortunately, then, about 6 months later, Trevor Weeks passed away. But at least they had the chance to celebrate him in time. Pearl Sandick and Jessica Galbraith-Frew and a bunch of other people organized a very successful conference in January, the Conference on Undergraduate Women in Physics for the Rocky Mountain chapter of the American Physical Society. Very well attended, a good set of speakers also for the conference. Jordan Girton helped to organize a conference that was held at Georgia Tech that was aimed at TA training and preparing TAs for leadership in STEM education, and had a very distinguished roster of educators from various different universities around the country attending. The Sloan Digital Sky Survey folks organized a conference at Deer Valley in July, and here's the army of attendees. 150 participants. That just finished last month. Then we have a number of outreach events that the department is involved in. So I've listed a bunch of these. I won't read the list, but I will give you some illustrations of some of them. Here's our own Adam Beeler doing one of his many demonstrations with audience participation. They're working on trying to separate two phone books with pages interleaved. This is a demonstration of how friction works. And it takes, even this many participants can't pull them apart. So all the king's horses. We had a very well-attended Physics of Freestyle event in the spring, last spring at Park City High School. Several hundred high school students, and Adam Beeler became one of kind of a rock star of physics demonstrations as a result of this. Got a whole bunch of people very excited about physics. They also had one of the Olympic slope-style skiers involved in demonstrating on a trampoline. So it was very exciting presentation. And then, of course, we have star parties also every Wednesday, Wednesday night on South Physics, at the top of South Physics. Paul Ricketts, Tabitha Bueller are some of the key players in running this, and plus some students that help out. And here is a bunch of people looking through one of the telescopes on the roof. The main telescope, of course, is this one that's underneath the dome. A nice picture of the telescope and the nighttime view. If you ever wondered how that thing got installed on the roof of South Physics, we were just recently beneficiaries of a bunch of slides from Don Groom that showed how they built this thing. So here's how you build an observatory. You start by preparing the mount, and then you hoist down from the sky. That's where it is. I think it's a sky hook or something that's dropping this thing down to the mount. That's the telescope. And then you start putting down the enclosures. and then put the cap on top. So it's simple as that. And you have your observatory. 1971. So these are scans from old Kodachrome slides from Don Groom. And that telescope produces some very exciting images. So here's one from a supernova in, near M82 in January 24. We had a special viewing event for that supernova so the public could come in and look at that. So these programs are important for a couple of reasons. They excite the public about science, so they're good publicity for the department. They're also attractive to donors for the department because they like to support this kind of activity. Some of them are avid amateur astronomers as well. And it helps us recruit students because young folk who come to these star parties end up eventually considering going to the university, and they might come here. So we opened an outreach center in the 4th floor of South Physics. It's really essentially a small area of the 4th floor so that we can have these events. And just to celebrate the completion of the construction of that remodel, we had an opening on June 10. We scheduled one for donors and bigwigs. So this was kind of a fundraising event. And then on the next day, we opened it to the general public. And here's Wayne Springer talking about how one can run the Frisco Peak Observatory on Frisco Peak in central Utah remotely from a control panel in this room. So this is now makes it possible for students to do projects on that telescope. This summer, we ran a very successful REU program, or I should say Professor Saviz Safarian and Tino Nyawelo organized a very successful symposium. This is a picture of, not just symposium, but program. We have a number of participants in REU here, and also mixed in are some of our own students who are also engaged in research. This is a list of a number of people in the department who are involved. Bob Cady took the students down to Moab and gave them a rafting trip. Ed Munford gave lessons in the machine shop. And we had a number of faculty members I've listed here: Perez Simcoe, Doug Bergman, Jung Jung, Shanti Dimya, Dave Kita, Michael Rashinin, John Matthews, Gordon Thompson, Anil Seth, Inez Ivans, and Vikram Deshpande, who took students into their laboratories or they gave presentations. And so this is essential for making this thing happen, is having research projects that these students can work on. And also graduate students involved: Carl Ebeling, Dylan Gregerson, Kevin Davenport, the GSAC folks, and the WAMPA folks. So this was a very successful program. We're looking forward to another one like that. And Saviz Safarian is also requesting that that it would be nice to get a little help from some faculty members in the selection process next year, picking the students who are successful in coming to our REU program. The REU program ended with a Physics and Astronomy Research Symposium. And this was not just for the REU students. It was open to all undergraduates and even graduate students who are engaged in research, and gave them an opportunity in an informal setting to present the results of their research. So this is the schedule. It took place July 28th, so just a couple of weeks ago. And if you look at this, you'll see that Professor Dimyad's lab had 1, 2, 3, 4, I'm probably missing one, 5 in here. A very large percentage of the students came from that lab, which is why you might think that she ended up getting that Myriad Award for excellence in undergraduate research. Here's one of Professor Dimyad's students, Florence Doval, giving her presentation. She won second prize for that. And here is one of our Simcoe students, Travis Morrison, giving his presentation, and he got first prize for that presentation. So I would encourage all of us to make a point to send our students, or if you're a student, to go to this symposium. If it's held next summer, I'm sure it's going to be because it was such a useful thing. Then we have some upcoming conferences in the coming year. In fact, one of them is starting just tomorrow. Professor Bardini is running a small conference on organic spintronics. It's the 10th anniversary of the seminal Nature article on spin valves, and so bringing in a number of people from the outside. Jordan Girton is running a conference that starts on Sunday, and that goes for about a week. And then in March, there will be a snow cluster and snow dart conference run by these faculty members here. This is the poster for Jordan Girton's conference. Then this is not a conference run by our own faculty, but I just want to call people's attention to the APS Four Corners Conference coming up at Utah Valley University, October 17 and 18. The abstracts for this are due September 12, and this is a great place for students to get experience in making presentations. So I would encourage everybody who has a research project to present to attend. We don't have to pay for airfare to get there, so it's a nice opportunity. Well, coming back to achievements, we have a number of our younger faculty who have gotten new funding in the last year. Adam Bolton got a DOE Early Career Award. Actually, that's probably slightly over a year ago. Saviz Safarian got an NIH R21 grant for some of his work. Professor Dean Miad got an NSF Career Award. Anil Seth, an NSF Career Award. Pearl Sandik got a regular NSF, her first regular NSF grant. And Dima Hasin is probably going to get an NSF grant. It's listed on Fastlane as approved. So it's in the works somehow. And Tino Nyawelo continues to be successful in getting funding for his refuges program. So these are all very commendable achievements. So priorities now, this is last year. Now we're going to talk about the coming year. So priorities for 2014-15. Well, this was one I listed last year, but we have people rolling up their sleeves working on this now, is the revision of our undergraduate major tracks to make them more coherent, to bring them up to date so that they're more relevant to our undergraduates and fit what we think the mission of our department should be. Development, meaning fundraising. We're going to continue pressing on this and working with the College of Science and getting more support from our donors. The new building project, this of course is very much on our minds because we're run out of space. And the space that we have is not state-of-the-art. We've had a study in 2013 by MJSA architects of various different options. They were looking at extensions of the buildings we have, as well as a completely new building. That turned out to be the most preferred option. But in order to make any progress, the path forward requires integrating our needs into a campus master plan. And so we're continuing to press our needs so that this becomes a high priority for the campus. And also it requires concerted fundraising, which comes back to the development issue here. So if you know any rich uncles or somebody who's selling their company that made a lot of money, let us know, because we would like to meet them. One of the things which is also, we're very active and actively involved in, Jordan Girton particularly, because he's chairing the design committee, the Crocker Science Center, which is, we're hoping we will get support from the legislature next spring to go ahead with construction. But the design effort is going on right now, and the idea is to renovate the Talmadge building where the old Natural History Museum used to be, or if you're really ancient, the old library used to be, on President's Circle. This is the back view looking at the Cell Center, an architect's conceptual design. This is what the atrium of that building might look like. Then TA training is going to be a priority this year. We started already, got off to a very good start with a TA training program just last week, run by Professors Sam, Gerten, and Sandik. And we're going to continue through the year with some ongoing mentoring. That process is still being worked out, but we want our TAs to take a professional approach to the jobs that they're doing, whether they're in the classroom or in the laboratory or just grading, and we want to help them in their professional development this way, and so that's what this process is all about. Also, we have a graduate student professional development program which is going to run this fall. The fall semester course, it's a course, a pilot course, and it will run Tuesdays from 4 to 6, which is sort of the Tuesday-Thursday counterpart to the colloquium, and it starts September 2nd. So next week in JFB 206, it's required, in quotes, of all beginning graduate students, and also some of our second-year students, selected second-year students, will also be invited to attend this. One of the things that we would like to see come out of this is students submitting proposals this fall to the NSF to get graduate research fellowships that would help, in an indirect way, help the department finances. It would help the students a great deal because their salaries would go up by about 60% if they actually got one of these fellowships. So that would be really good for the students too. Well, next I'd like to just present some research highlights that my colleagues provided me, and as I said, I hope that I don't butcher things too much when I do this. Condensed matter theory. Professor Efros, he has been working on supercrystals. These are, I guess these are sort of crystal arrays of nanocrystals. So each one of these things is a nanocrystal, and then you put it together to make a supercrystal. And then you study the photoelectric effect, photo and dark band conductivities in this thing. So there's these things are kind of amusing because they're an ordered array. They have a conduction band, they have a valence band, and studying the properties of light, photoexcitation of electrons in this crystal. So interesting, novel type of material. Condensed matter theory, Professor Payson is working on low-dimensional systems. Graduate students listed here, and an undergraduate student. He's recently published on vial semimetals, gapless topological phases, looking at how the chiral anomaly affects non-local transport in the spectrum of collective modes in this material. So it's fascinating stuff and interesting theory. So he's produced 2 papers and also, as I mentioned, is on the verge of getting funding for the project. Professor Reich. Now, I hope that Misha doesn't mind that I took that nice poster that he gave me that would not possibly fit on this thing, and I pulled out some pieces from it. And so I hope I haven't, this is the one that I probably butcher the most. But Robert Roundy, a graduate student, and he have been looking at carrier transport in these organic spin valves. So this is looking at how the electrons hop from one site where it's being injected to a sink over here, and what happens to the orientations of the spins. The idea is that when you apply magnetic field, the conductivity changes, and the spin orientation also changes. Looking at the efficiency of these organic spin valves and how they're affected by precession of the carriers in these random on-site hyperfine fields, looking also at tunnel magnetoresistance. And so they looked at this and noticed that the magnetoresistance can actually take on negative values under certain circumstances in one dimension. These are some results that they presented in the poster, plotting the average spin versus some scaled quantity which includes the magnetic field. I guess that tau is a diffusion time and the time of transport. And under certain conditions, you get a negative value of the expectation value of the spin. So did I do that right, Misha, or do you have something to add to that? Sorry? Yeah, I'm sure it's well beyond what you expected I would do. Yes, okay. Okay. Professor Alien, although he's not producing research in his laboratory, is still involved in on the executive committee of ISMAR, which is an International Society for Magnetic Resonance, and he wanted me to mention that there is a conference planned in Shanghai by the ISMAR folks in August 2015. So that's just a little less than a year away. Condensed matter experiment, Professor Verma has been working on the way nuclear spins can affect currents, which is kind of an interesting phenomenon in organic LEDs. And so I can't possibly go through this whole slide in just a minute or so. But in any case, the interesting phenomenon is that the currents in these materials can be sensitive to the nuclear spins. And you can manipulate them and vary them and you can use the currents in order to measure magnetic resonance, detect it, and so it's a very interesting phenomenon. I guess it also fits under the heading of what you would call spintronics. Professor Deshpande gave me some information, nice slide, showing how he's setting up his laboratories downstairs. He just arrived just this past year. And he's setting up a synthesis lab so that he can make interesting two-dimensional materials. He wants to explore new 2D materials, van der Waals epitaxy, and looking at various other physical and properties of these two-dimensional things, graphene and other kinds of things. So his lab is getting set up downstairs. So we look forward to some interesting results coming from that in the near future. Professor Gerten does work on high-resolution microscopy, and here he has a slide showing beaming of photons using a nanoscale tip. Well, I guess I don't, if Jordan's here, he can help me a little bit with this, but I think that's simply in a nutshell what is involved. So the idea is to make a microscope that can measure at very short distances. I mean, this is nanometer scale here in the optical. Condensed matter experiment, Clayton Williams, has been looking at the behavior of ferrocene dicarboxylic acid deposited on calcite surfaces. So what's interesting is that this material forms little islands on the calcite, and it doesn't just deposit uniformly, but it clumps like this. And then you can, by running an AFM probe tip over it with a current, you can inject electrons on this and then observe various molecular orbital excitations in the ferrocene as a result of introducing electrons. And so this is a plot showing how that process can be done. This is extremely sensitive and very interesting to be looking at single electron effects on a surface like this. Condensed matter experiment, Professor Vardini is working on giant magnetoelectroluminescence from hybrid spin organic LEDs. here's a diagram of an organic LED. And I think these are the key words in here. It says, our team has demonstrated substantial magnetoresistance and magnetoelectroluminescence at room temperature based on an innovative device that incorporates an inorganic magnetic tunnel junction, and that's this thing here, and an organic light-emitting diode in the right panel over here. So manipulating light emission in these materials, and it might have some interesting technological applications down the road. Oh, see, I guess there was another piece to this which shows up in sequence. I didn't. Okay, well, all right. So here we have electroluminescence intensity as a function of the magnetic field. You see what it changes when you change the field, and it pops back up again. Which is interesting effect. Astronomy. So Professor Seth has an article which has just been accepted by Nature, is about to come out. So should I be talking about this now or no? It's okay. All right. The Nature sometimes gets very fussy if the cat gets out of the bag before you buy the article. 20 million solar mass black hole detected in, that's an enormous black hole in NGC 4647. 120 million, so it's in a strip. Oh, you can't see it. Oh, yeah, that's not it. That's just a cluster of stars. All right, there it is. And so this is a very interesting discovery, and I guess you found this by looking at motions of stars and inferring from that the mass of it's the usual way from the kinematics. So he has students working on a couple of projects. This one is by Jiu Nguyen, one of his graduate students, looking at a small starbursting galaxy called Heniza 2-10, and finding that it's 3 times more massive than previously thought. Anyway, so an interesting discovery based on, I guess, again, on kinematics. And then here is work by Brian Kimmig, looking for Milky Way globular clusters within the Milky Way, 25 new globular clusters. Professor Zheng gave me a slide showing a recent discovery of a very high velocity star. This was found in the LA MOST, I'm not sure exactly how they like to pronounce it, facility in China. So there are a number. China's been investing quite a bit in this kind of research, and there's a glitzy new observatory that can measure these things, looking at the spectroscopy, I would guess. And this thing, the velocity with respect to the sun is 620 kilometers per second, which seems quite high. I'm not sure how to put that in context. Maybe a more typical fast star would be 100 or something, I guess. So that's pretty fast. Also advertising an opportunity for an R8, if anybody's looking for one. Professor Bromley, is he here? Ben? Ah, yes, there's Ben. You're going to have to help me with the next slide. So Ben is doing planetary dynamics from the microscope. So how you build planets, starting from the smallest grains and working your way up. So studying meteorites to look at what grains are like. Then hunting for planets as part of the process. Once you make them, to see where they are. Also galactic dynamics, which is, I guess, a giant solar system, kind of. Also looked at what is Pluto. Charon, what are they? A bunch of students he has working with him, also with Europe. And then, let's see, there is planet 9. That would be the new Pluto.
Planet 9 is implicated by the orbits of very distant dwarf planets.
So there's something out there lurking to be discovered. Okay. Outwardly scattered planets can resettle on new orbits by gravitational interactions. Super Earth, a super Earth lurking. Oh, you saw it. There it is. Okay, very good. It made a lot more sense in motion than it did when it was a still. Okay. High energy astrophysics with Dave Kita and Wayne Springer. So they're involved in this HAWK experiment in Mexico. This is a high altitude water Cherenkov detector. So what we see in this picture here is a whole bunch of cans full of water. And then when ionizing particles pass through them, they produce, I guess it's Cherenkov light that they're looking at, and they get detected so that this thing becomes a kind of a ground array detector for cosmic ray air shower. This is a picture of it scattering. They could just look at it like this and see that it's red. They wouldn't have to use the water. No, I'm sorry. Yeah, just optical cameras would work. No, but this detector is being, I guess, being commissioned and is starting to run. And here they are detecting the Crab Nebula, which is, I guess, the sort of the first thing that somebody does when they set up the array, because it's a very bright object in the sky in high energy gamma rays. And they're looking for small scale anisotropy of cosmic rays. So Dave or Wayne, is this actually a new result which has just appeared? The paper's just coming out. Okay, great. So looking for the hotspots. Speaking of hotspots, so then we have the cosmic ray group: John Bells, Doug Bergman, Charlie Ray, John Matthews, Pierre Sokolsky, and Gordon Thompson, looking for hotspots in the particle spectrum at very high energies. And this was a recent discovery that received a lot of press. They found in a region of the sky which is fairly broad, evidence for it's near the Big Dipper, a hot spot with a 3-point sigma. Let's see, well, that was 3.4. That was the old one. I think the new one is 4.6. Now with the new measurements, 4.6 sigma probability of not just being random, but actually being a real effect. So that's very interesting. It's the first time that I think I've seen a result from the cosmic ray group that has actually demonstrated anisotropy. Like has been looked for a long time. So this is very interesting because, of course, we want to know where they're coming from. And the first thing you need to know is where are the sources. And this is on the track of locating sources. And the other thing that comes from this telescope array experiment is our measurements of the spectrum at lower energies. And what's interesting about this is that it's the same detector that, I mean, it used to be when I see these plots, I see these results. This comes from one detector, that comes from another detector, this comes from another detector. And you wonder about the systematics and have they pasted them together properly. But here we have one that is with the same detector measuring the spectrum over a very broad range of energies. And so it gives a lot more credence to this kind of picture that you see drawn in with the straight lines. John Bells has also got an interesting cosmic ray experiment, part of the same group, but he's working with some colleagues on Tara, which is a radar, uses radar to detect cosmic rays, or at least that's what they hope to be able to do, using bistatic radar. So again, out in the West Desert where the telescope array is, they are broadcasting on the television frequency and looking for reflections of the television signal when a cosmic ray air shower occurs. So this is still being set up and they're still looking for the effect. But if they do find it, it will open up a whole new way of detecting cosmic rays. Then here's another interesting side experiment that they're doing, looking at gamma rays produced by lightning. Now that's really astonishing that lightning could be producing gamma rays. And also looking for the possibility that cosmic rays could be stimulating the genesis of lightning. So is the atmosphere a giant spark chamber, and the cosmic ray passes through, and boom, you get lightning under certain circumstances. Professor Verschinen in biophysics is looking at molecular transport, molecular motors in cells. And this is a picture of a cytoskeletal network of filaments, and the motors run along these filaments. And the question, I guess, that this is dealing with is what happens when the filaments cross? And you have this little motor coming up to the intersection. Does it know what to do when it gets to the intersection? And the answer is that when the angle gets close to zero, anti-parallel, the cargoes get stuck. So, but you know, this is interesting mechanics issue, which is very important. I mean, we depend on these motors to stay alive, so we need to know how they work. So that's what I had for highlights for all of the research. As you can see, we've got lively research program going on, and I hope that I didn't butcher people's research projects too much in this talk. So that's the state of the department. The state of the department is it's good. We have a lively research program, and we look forward to more exciting developments in the coming year. Thank you. Okay, well, I don't think that was a talk that required a lot of questions, but maybe if you have any. The next event is that GSAC is going to have a meeting after this colloquium, and Kevin McDonald, who is the chair of GSAC, you want to wave your hand to everybody, huh? Kevin Davenport, excuse me. I don't know where that came from. Davenport. And Kevin would like all of the Graduate Student Advisory Committee members to stay afterwards.
Well, what we want to do is just before everybody leaves, we have sitting down there on this table just these forms. There's 5 professors. There's an email sent out. Hopefully everybody saw it. There's 5 professors this year that are up for the RPT, retention, promotion, and tenure. And we want all the graduate student body to take a look and fill out some of these forms to give us some feedback so that we can finish our report.
So you want all the graduate students?
All the graduate students.
All the graduate students to stay.
Graduate students, if you just grab one of these forms, and if you haven't had, if you're not familiar with these professors or anything, you can just simply, there's a spot on the bottom of the form for each professor to vote yes, no, or abstain. You can just abstain. But if you have any feedback about any of the professors, you've had contact with them, the more information that we can get to make our decisions, the better. So any of you can give us a grade. It shouldn't take very much time. There's some pencils down there as well, in case you don't know where anything. Please take time to do that. We'll collect them.
Okay, thank you.